Imagine crossing 300 to 600 kilometers in the time it takes to grab a coffee. Today, we unpack the Hyperloop story, from the spark of the idea to the first human ride in a vacuum tube. We will keep this factual, cut the hype, and focus on what is proven and what is still experimental. Welcome to Elemental Science Magazine. Origins. The modern Hyperloop concept was publicly outlined in August 2013 when Elon Musk released the Hyperloop Alpha paper proposing sealed low-pressure tubes with electric propulsion and streamlined pods. The illustrative route ran Los Angeles to San Francisco in about 35 minutes, with peak speeds near 760 mph, approximately 1,220 km/h, and frequent departures in small capsules. The paper emphasized partial vacuum to slash aerodynamic drag and linear electric motors to accelerate pods, with air bearings originally proposed for levitation. Why a tube at all? Drag increases with the square of speed. Take most of the air out, and you dramatically reduce drag. That is the core efficiency play. A controlled, near-vacuum environment, plus contactless levitation to minimize rolling friction and allow sustained high speed on electricity alone. Hyperloop is not a plane, not a train. It borrows from maglev rail and aerospace pressure vessel practice in a new configuration. Early momentum and competitions. Following Hyperloop Alpha, independent teams and startups formed. SpaceX built a 1-mile test tube for university pod competitions. Student teams achieved very high unmanned pod speeds in that environment. Meanwhile, commercial players began building short test tracks to integrate vacuum, levitation, propulsion, and controls as full systems, moving beyond lab rigs to life-size hardware. The first full system and first human ride milestones. Full system tests in a low-pressure tube began in Nevada in 2017 with progressively higher speeds. On November 8-9, 2020, a company test team conducted the first human ride in a Hyperloop pod at the DevLoop track outside Las Vegas, reaching about 172 km/h on a roughly $500 run. This was not a top-speed run. It was a tightly controlled, safety-focused demonstration that proved you can seat and secure people, depressurize a tube, and run a levitating propelled vehicle with passengers on board. The Verge. What that first human test did and did not prove. It proved core interfaces, passenger capsule pressurization, emergency and restraint systems, propulsion and levitation in a depressurized environment, and procedure discipline. It did not prove long route economics, mass evacuation in a tube, or comfort at extreme speeds and tight radii. It was a safety step, not an end state. Technology stack in plain language. Tubes, steel or concrete shells segmented by isolation valves to compartmentalize pressure. Pumps, distributed vacuum pumps maintaining low pressure. Pods, pressurized like an aircraft cabin with life support, sensors, and autonomy. Levitation. Magnetic suspension is now the dominant approach in most efforts. Some early concepts used air bearings. Propulsion. Linear electric motors spaced along the guideway to push and pull the pod's onboard magnets. Braking. Regenerative electromagnetic and eddy current braking to slow without contact. Safety thinking. The tube is divided into sections, so a leak can be isolated and repressurized. The vehicle must be able to stop under control, maintain breathable air for passengers, and reach an egress point. Spacing between pods must ensure one pod can brake hard and the next can safely respond. Much of the engineering work before public service is about emergency scenarios. Leaks, power loss, object intrusion, fire, and seismic events. What happened next in the industry? One of the most visible startups that achieved the 2020 passenger test later pivoted toward freight and ultimately shut down in late 2023, selling off assets after failing to secure a commercial contract. The shutdown did not invalidate the physics but highlighted the commercial and regulatory headwinds. Meanwhile, European and Asian programs pressed on with standardized testing and national R&D support, where full-scale testing stands now. Europe opened a 420 meters test facility in the Netherlands in 2024 to validate lane switching and integrated subsystems. By 2024-2025, Test runs with levitation were demonstrated in that tube, with speeds ramping up in stages. China's CASIC reported sustained testing on a 2-kilometer low-pressure track, surpassing 623 km/h with a superconducting maglev vehicle in early 2024. These are still test environments, but they show a geographic shift in momentum. The Guardian means closing. The verified state today is a working set of subsystems, a first human ride at modest speed, and multiple government-backed testbeds. The open questions are certification, economics, scalable construction, and emergency doctrine. Hyperloop is past the sci-fi sketch, but not yet a public utility. The next few years of standardized testing and pilot routes will decide whether it becomes a mainstream mode or remains a specialized freight-first technology. Thanks for watching. Subscribe to Elemental Science Magazine.